Stan Gibilisco here. I'm going to explain spherical coordinates in a context that is somewhat easier to understand than comparing it to the XYZ Cartesian system of three-dimensional coordinates. Spherical coordinates. We might think of the north-south direction as the x-axis, the east-west direction as the y-axis, and the up-down axis as the z-axis, all with an origin right where you are. You can define the position then of any point P in space according to how far north or south, how far east or west, and how far above or below the horizon that point is. This flat looking thing, this hash marked thing, the XY axis or the east, west, north, south axis is the plane of the horizon. That's straight up, that's straight down, that's you. So you can define your position of the point P as in Papa according to a certain distance in those three directions, x, y, and z axes. Also, you can define it in terms of angles, where theta can go from minus 90 degrees straight down to plus 90 degrees straight up. So a range of 180 degrees. The angle phi can go all the way around the compass directions, starting with 0 degrees at north and going clockwise. 90 degrees goes east, 180 degrees goes south, 270 degrees goes west. And then of course the radius r is how far away is that point P, Papa, from you. So according to these two angles and one radius, you have what is known as spherical coordinates. Now this is just one method of doing it, and it's not the mathematically rigorous method that you're likely to encounter in your analysis or calculus courses, but it's something a little more down to earth, figuratively and literally, so to speak. Why do we call it spherical coordinates? Well, because the point P, as in Papa, lies on a sphere with a certain radius, and that sphere can be defined according to the vertical circle going according to the angles theta, and the horizontal circle going according to the angles phi, so that you can sort of envision those circles at right angles to one another as a sphere, or as the basis for a sphere. 90 degrees meaning that the zenith and the nadir are at right angles to the horizon, or the plane of the horizon. So you define the coordinates as theta, phi, and r in order to get the position of your point P. Now, of course, you could call this x, y, and z axes, and then define P according to coordinates x, y, z in a Cartesian three-space. And then, of course, formulas exist for deriving spherical coordinates in terms of Cartesian and vice versa. But that is the basic concept of spherical coordinates. Two angles, one in the horizontal plane, one in the vertical plane, and a radius, which is the distance of the point P, as in Papa, from the origin, which is where your head is. Stan Gibilisco signing off. Until next time, so long.